Good morning, students. Hope everyone prepare previous chapter 7 videos classes. Okay, chapter 7, that is we discussed here previous class, complexity, how to calculate complexity of algorithms by using examples. Okay, up to now we discuss time complexity, internal factors and external factors. What is meant by complexity? What is meant by how to calculate time complexity? What is meant by space complexity? What is meant by best average and worst case scenario? We last class discussed that concept. So last class we discussed whether a given number is a prime or not. We decide and we calculate the time complexity of that problem. By using one technique. Today we discuss same program with another technique. We calculate here time complexity of the same program, that is prime, whether a given number is called as a prime number or not. So for that we use another technique here by using root n technique. This one is square root n technique. Last class we discussed same problem or program by using the linear sets technique, that is linear technique for calculating the given number is prime or not. Today we discussed same technique, same program with a different technique. The name is here root n technique, to find the whether the given number is prime or not. This program depicts the how to calculate whether the given number, what we have to enter from the keyboard by the user. That is, we check here whether it is prime number or not. So last class we same program can be discussed, but the difference between from the last class to this program. So in the last program we place here for loop, but that for loop repeated n times. So that for loop repeated n times. So that program consists of the logic, depends on the actual fundamental concepts on the prime number. That is, suppose one number having more than 2 factors, more than 2 factors, it is not a prime number. So by using that logic, we conclude whether the given number is prime or not in the previous class. But in this today's class, in this program, we discuss same program with a different technique, that is root n approach. Root n approach. Here the loop, in that program, previous program, n times repeated loop, but here the number of loop iterations decreased, because here we are using root n. N is greater when it compares to root n. That's why here the number of comparisons or loop repetitions decreased. That's why this program is efficient when it compares to time complexity. So last program, the time complexity of that program is n, but this time the complexity, when we complete the time taken, the time complexity is here root n. Why? Because here root n times this can be repeated, this loop, while loop. But last class for loop we are using, that for loop can be executed n times. That is the difference between previous program and this technique. See here prime, last class we discussed prime flag is also 0 here. This time we set the prime flag is 0. When the prime flag, okay, is 1, that is the number is a prime number. Otherwise it is not a prime number. Okay. Initially we set a prime flag is equal to 0. That means we are considering it as a prime number. Then we decide whether the given number is prime or not. Depends on the logic. So from the last technique and this technique is difference is last class we discussed. Okay, we count from for loop 2 to n rhymes repeated, but here root n times. We are calculating here I square. Okay, I square is less than or equal to n here condition. So then I is equal to root n. So root n times repeated this loop. Okay, see here first you take one. Okay, first you take one number from the keyboard. Here n is, for example, n, set n. User enter the number 5. Then you set a prime flag. Prime flag set to initially 0. Means you are considering it as a 0 means initially prime flag set to 0. Then if the number, okay, execute this logic, it changes whether it is 0 or 1. Suppose if it is 1, prime flag set to 1 finally, then it is a prime number. Suppose if the prime flag not set to 1, that is set to already 0, okay, then it is not a prime number. So previous class also we same, logic is different but final answer is same. Okay, so same program with same output but different logic applied here. So then we last class we calculate time complexity. This time also we calculate time complexity. Okay, compare these two time complexities. Then we decide which one is the best one according to time complexity. Okay, see here in this prime flag already set to 0. Here we start with I. Here I is called as I is loop control variable. So I is used in this loop while loop. That's why it is called as I is called as loop control variable. So while initially I is equal to 2. Okay, initial condition. So while condition, while loop having condition, the condition I square. Here we decide calculate I square, I into I. Condition checks with n. If I square is less than n, means I square is equal to 4. I square is 4. Okay, you calculate I square is less than, I square is equal to 4. Is less than or equal to 5 or not? First you check. Is less than or equal to 5 or not? Every time n here. Here n means 5. Okay, if n percentage I is equal to 0, n means here 5, percentage means it returns remainder I. So you divides the 5 with the 2, then you return here not a quotient, remainder. If remainder is equal to 0, if remainder is equal to 0, okay, it is a factor. I is a factor of this number. But here is not equal, 5 percentage 2 is not equal to 0 here. That's why, so 2 is not a factor of 5. Here we calculate factor by using the same logic last class we discussed. But here comparisons are decreased. I square times, we compare I square. But in previous class we compare n times. I compared with n. Here I square is compared with n. That's why here I square is equal to n. I is equal to square root of n. Comparisons, n is less than, n is greater than root n. That's why, so it is not a prime number. Then you again, okay, so not equal to 0. That's why I is equal to I plus 1. Then I is changed to 3. Okay, I is changed to 3. Why? Because prime flag is not equal to 1 here. not set to 1. So that's why we come to this, not this statement, not comes under this break statement. Then again I is equal to I plus 1, means I is equal to 3. Then again compare 3 square 9. Here I is 3, I square 9 is not equal to 5. That's why we will not enter into this body of the loop. Then again come prime flag already not changed here. Okay, prime flag not changed here. That means prime flag is set to 0. So if prime flag means 1, okay, if true, prime flag means 1, 1 means true. Okay, so print n is a prime number, but here prime flag set to 0, 0 means false. So else part, print n is not a prime number, 5 is not a prime number. So how to decide this 5 is not a prime number? We not check every number 2, 3, 5, 4 up to 5. Last class we discussed. We check 2 first, after that 3, after that 4. In this way we check n minus 1 times, nearly n times. But here we not check 2, 2 square, 3, 3 square, 4, 4 square. Like that we reduce the number of comparisons. Okay, so that's why this technique reduces the number of comparisons and time. So this one is best one among two techniques. Then we calculate practically this program. We evaluate the time taken for this program, for each and every step of this program. So we assign time complexity for each and every statement. Then we calculate total time taken by to execute this program. Then we decide which one is the best one, which technique is best one. Okay, so first technique or second technique is best one. We decide that one. Okay, see here. Here, see, this first statement we assign time complexity constant time, that is constant time, that is C0. Okay, next, this one is one statement. To execute this statement we set a constant time C0. Here we set constant time C1. Okay, this statement C2, I is equal to 2. Okay, as for assignment of this value C2, then we comparison condition here. Condition is to evaluate the condition. Okay, here C3, we assign C3. Here the condition checking, if okay, this one is C4, this one is C5, this one is C6, this I is equal to I plus 1, C7. Okay, in this way we assign each and every statement, every computation, and for every calculation we assign here constant time C0, C1, C2 to C7. But this one is while loop. This while loop executes root n times. Root n. Why? Because I square is equal to n. I is equal to root n. Okay, that's why we compare this condition while loop executed repeatedly root n times. That's why here we assign root n times. Okay, root n times. So loop executes root n times here. Okay, next. So then finally we calculate, okay, the time taken by to execute this program is so C0 first statement, time taken, total time taken is equal to C0, initially C0 plus C1 plus C2. Okay, C0 plus C1 plus C2. Again, next statement is while loop. That's why while loop executed root n times. Root n into body of the while loop statements here. Okay, so here condition takes C3 times plus, okay, next C4 plus C5 plus C6, okay, C6, see here C3 into root n, C4, this can be executed root n times. So root n into C3, root n into C3, C4 plus C5 plus C6 plus C7 plus C6 plus C7. Okay, next plus, so assigning this one is if condition C8, print statement C9, okay, after that C10. So again C8 plus C8 plus C9 plus C10. So here the total time taken to execute this program is C0 plus C1 plus C2. This one is, all these are constant. Okay, plus root n into constant plus constant plus constant plus these are all constants. Okay, that's why here, okay, this one is constant. So constant time. So we assign this one. C0 plus C1 plus C2 constant. This one is also constant. This one is also constant. So constant plus root n into C3. This one is also constant time, plus this one also constant time. So next constant plus constant. This one is constant, this one is constant. Constant plus constant is equal to constant. Okay, so this one. So finally the answer is root n into C3 into constant time. We negligible, we can take only the nth term, means dominant term here. Here the dominant term is, so the big O notation here, the dominant term we consider here only the dominant term. So we consider here the dominant term is, so order of n, big O notation order of n is equal to root n into C3 finally. Then we calculate only here dominant term. This one is dominant term. That's why here root n. So order of n is equal to root n. Okay. So this second technique, when we calculate whether the given number is prime or not, here the big O notation, the time complexity is root n. But the previous program technique, the order of n is equal to n. When we compare these two, okay, order of n's, so always root n is less than n. So always root n is less than n. That's why the time taken of all these two techniques, which one is the best one? Root n. This technique is best one to compute whether the given number is prime or not. In this way, we calculate manually. Here we calculate manually. Actually, the calculation part is decided by the operating system. So this task is the job of operating systems. So that's why we decide time complexity in this way. So this is the today's concept. Next class we discuss one more time complexity with examples. Okay. Thank you, students.